Welcome back to my channel, everyone. Today we are back with another tutorial and we are going to be learning systems of equations. And this is a two-part series, and in this part we are going to be going through how to solve these systems of linear equations graphically and solutions, what exactly that means and what exactly they are. So, what exactly is a system of equations, or a system of linear equations more specifically? And that is basically when you are given more than one equation, you have to find the solution. And the solution is the point of intersection, or the points of intersection between those equations. So solving graphically normally involves two main steps, and that is basically you just graph the equations and then you find the point where both of those lines intersect, and that is your solution. The best way to understand is by doing examples. So let's do this one. Alright, now this is a system of linear equations. And what that actually means is both of these equations will result in a straight line when you graph them. That's what a linear equation is. There are a few ways to start this. You could either put the equations into slope-intercept form, which is what we're going to do, or you could determine both of the intercepts for each line to graph it, or you could just create a table of values for both of those lines, but that kind of takes a lot more work. So we're just going to put both of these equations into slope-intercept or y-intercept form. And that form is y equals mx plus b. And if you're not really sure how to do that, well, lucky for you, we're about to go through that right now. So let's start with this first equation, x minus 2y equals 3. It's quite simple. You just have to isolate y. So we can start by moving x to the other side. So if we have x minus 2y equals 3, we can just move x to the other side. And then we have negative 2y equals 3 minus x. We divide both sides by negative 2. And then that leaves us with y equals negative 3 over 2 plus x over 2. Because this would become minus negative x over 2, which, two negatives multiplied together give you positive. So that's our first equation in y-intercept form. Okay, and now if we're doing this equation, this is a lot simpler. We have x plus y equals 0, and then we just move x to the other side, and that gives us y equals negative x. And that's our slope-intercept form for equation 2. Now, to graph it, we just put values into x to get y. So what I mean by that is, let's start with this first equation. To find out y, we need to put in random values for x. So we can have negative 3 over 2 plus 1 over 2. When x is 1. So when x is 1, which is here on the graph, what is y? And if we have negative 3 over 2 plus 1 over 2, we just have negative 2 over 2, which gives us negative 1, which means when x is equal to 1, y is equal to negative 1. When x is 1, y is negative 1. So that's where the point is, because x is 1 and y is negative 1. Then we put in another value. So let's say when x is 2, so then this becomes 2. Negative 3 plus 2 is negative 1 over 2. So when x is equal to 2, y is equal to negative 1 over 2, which is negative 0.5. So x is 2, and then y is negative 0.5. So we're going to plot it where y is between 0 and negative 1. Now, we can see a pattern where the line seems to be going in this direction, and we know it will form a line because it's a linear equation. So let's try to find values that go in the other direction just so we cross quadrants. So we've done 1 and 2. Let's try 0. When x is 0, we have to find what y will be. So if we put 0 in here instead of x, we have negative 3 over 2 plus 0 over 2, and 0 over 2 is just 0, so that gives us negative 3 over 2, which is negative 1.5 in decimal form. So we have to find where x is 0, so it'll be in the center, and then y, negative 1.5, will be here, in between negative 1 and negative 2. You just plot as many points as you think are necessary. You can always plot more points later if you haven't found an intersection yet, but let's just plot one more to be safe. So let's try when x is negative 1. So when x is negative 1, we would put it here instead of x. We have negative 3 over 2 plus negative 1 over 2, and that will give us negative 4 over 2, which will simplify to negative 2. So when x is negative 1, find x negative 1 and plot it where y will be negative 2. So we can see that there's a straight line, and we'll just draw a line connecting these 4 dots. Okay, that's our first equation. Now I'll use the color blue for the second equation. Y is equal to negative x. This makes it a lot simpler because to find y is just going to be the negative value of what x is. If we put negative 1 for x, y will be the negative version of negative 1, which will be positive 1. They're just going to be opposite signs. So when x is negative 1, y will be positive 1. So we plot the point there. When x is negative 1 and y is positive 1. When x is 0, y will be negative 0, but that doesn't exist, so they're just both going to be 0. Then when x is 1, y will be negative 1. So then we plot the point there as well. And then let's just do one more. When x is positive 2, y will be negative 2. So this is when x is positive 2 and y is negative 2. And then again, we just draw a line through them. And we can very obviously see where both of these intersect. And it's right there. When x is equal to 1 and y is equal to negative 1. And that is our solution. So the solution of this system of equation is 1, negative 1. When x is 1 and y is negative 1, that is where the two equations intersect, and that is our solution. Now, what if you are given the system of equations and you are given the solution, and the reason they're in quotation marks is because you have to figure out if that is actually the solution or if it's not. In this question, we are given two linear equations. We have 3x minus 2y equals 8, and we have 4x plus y equals 7. And they're saying the solution is 2 and negative 1. When x is 2 and y is negative 1, and we have to confirm, is that the solution or is it not? In other words, is that where the two equations intersect graphically or no? Now, you could obviously just graph it and see do they intersect at 2 and negative 1, but that might take a lot of time. So you can actually just solve it algebraically without graphing it. So one way to do it is just to plug in the values that they have given you. So they're saying that when x is 2 and y is negative 1, that's where they intersect. Well, we can just plug in those values into the equations. And you have to plug in those values in both of the equations. So let's start with 3x minus 2y equals 8. So wherever we see x, that's where we have to put in 2, because they're saying the solution is when x is 2. So we put 3 times 2, and then for y, we're going to put in negative 1, because that's what they're saying the solution is, times 2 times negative 1 equals 8. 3 times 2 is 6, minus 2 times negative 1 is negative 2 equals 8, and then 6 minus negative 2, which, these two end up adding, so then that gives us 8. And this is correct, because 8 equals 8, obviously. But we're not done yet. We have to confirm it with the other equation as well. So we have 4x plus y equals 7. We again put in 2 for x and negative 1 for y. And 4 times 2 is 8 plus negative 1, which does equal 7. So this is also correct, and that means this solution is correct. Alright, but I'm going to show you an example when it isn't the correct solution. Okay, so now we have x equals 2y minus 9, and we have x plus 5y plus 5 equals 0. This is telling us the solution should be when x is negative 5 and y is 2. So again, we just plug in those values. X equals 2y minus 9. We have to plug in negative 5 for x and 2 for y. Negative 5 equals 2 times 2 is 4 minus 9. And that is correct. Negative 5, because 4 minus 9 is negative 5. So these two things do equal each other, so that's correct. But again, we're not done yet, and we have to also test the second equation. We have x plus 5y plus 5 equals 0. X is negative 5, so we have negative 5 plus 5 times y, which is 2 in this case, and then plus 5 equals 0. So we have negative 5 plus 5, and these can just cancel each other out and become 0, right? 5 times 2 is 10, and this does not equal 0. These two things do not equal each other. They're not the same, which means since plugging in those values didn't satisfy both equations, this is wrong. This is not the solution. So a system of linear equations can actually have a different number or amount of solutions. It isn't always just one solution. There are cases where you can have multiple and you can also have none. Let's learn those different cases so that you can identify them. Off with this first one, parallel lines, which are when they have the same slope but different y-intercepts. So a good way to remember this is literally parallel lines. When two lines are parallel to each other, that means they look like this, or they look like this, or they look like this. They have the same slope, meaning they're going in the same direction, but different y-intercepts, meaning they don't intersect in the same place. That's why they don't ever meet. They're going in the same direction the whole time, but they never cross paths. Okay, so let me show you an example. So we have 2x plus y equals 3. Again, we're going to put it into y-intercept or slope-intercept form to graph it. So if we have 2x plus y equals 3, we can move y to the other side. So we have 3 minus y, and then we move 3 to this side, and then we have 2x minus 3 equals negative y, and then we can just switch the signs by multiplying this with a negative 1 and this whole thing by negative 1. So then that gives us positive y equals negative 2x plus 3. And then we're going to just test different values for x and then find what y would be and then plot it. Okay, so obviously, as expected, we can see that this forms a straight line, but that's only one equation. Now let's try the other equation. Now we're going to do this one. Y minus 8 equals negative 2x. So again, let's put it into slope-intercept form and then put in values for x to find points for x and y and plot them on the graph. So this is simple. We just move 8 to the other side. So we have y equals negative 2x plus 8. Now we put in different values. I'll use the color blue. This also makes a straight line. And as we can see, these are parallel lines. They're both going in the same direction. They're both going from positive to negative, but they have different y-intercepts, which means they intercept the y-axis at different points. This equation, the first equation we did, intercepts y at 3. And the second equation we did in blue intercepts y at 8, which means they are going in the same direction, but they don't cross the axes at the same point, and they never intersect. These will keep going, and they will never reach a point where they cross over. So in this case, there is 0 solutions. If you have parallel lines like this, they will never intersect, and there will never be a solution. Okay, now the second case, we have coincident lines, where isolating y gives you the same equation. Let's see, we have x plus y equals 3. If we isolate y, this is really easy, we just go y equals 3 minus x. We just move x to the other side. Okay, and now let's do this equation. We have 2x plus 2y equals 6. Well, we can just move 2x to the other side. We can just subtract 2x from here and subtract it from here. These cancel, so we have 2y equals 6 minus 2x. And then we divide both sides by 2. And we have y equals 6 divided by 2 is 3. Negative 2 divided by 2 is negative 1x, which is the same thing as 3 minus x. And we can see both of these equations are exactly the same. And what that means is if we graph it, if we were to graph both of these equations or either of these equations, it will look like this. Both of these equations look like this. Exactly. They intercept y at the same place. They have the exact same points. It looks like this. And when you have coincident lines, these have an infinite amount of solutions. Every single point is an intersecting point. If we graph this from here to here, every single point is a solution because it's the exact same equation. The last case scenario, which we have been mostly working with, is intersecting lines. When you have different slopes, but eventually the equations will intersect. Let's isolate y. We have, for this equation, we have 4 minus 2x, and then for this one, if we isolate y, it will become y equals 3 minus x over 2, or 1 over 2 times x, same thing. Again, we'll just put in random values for these points and graph them. Okay, and this is a straight line, and then these also form a straight line, and we can see that they intersect over here. That is when x is, I want to say 0.5, and when y is 2.5. So there's only one solution where both of these equations intersect, and in this case it was 0.5 and 2.5. Okay, so those are the 3 different kinds of scenarios. That was a tutorial. I hope you found this helpful, and stay tuned for part 2 of the series. And yes, I will see you guys next time.